Hey everybody, we're going to end Unit F with inequalities involving angles and sides of triangles. Has to do with the three sides of a triangle, and we're going to compare them here. Comparison property of inequality. This is actually a pretty easy concept to think about. Assume that A equals B plus C. So obviously, if you said of those three numbers, which one would be the largest, A would logically be the largest unless something was negative, but we're going to assume that nothing is negative here. So A would be larger. We also know that C has to be greater than 0. So if that's true, then we know that A has to be larger than B. That's a pretty logical statement to say right there. We have the triangle exterior angles theorem, which we remember from a while back, says that the exterior angle is equal to the two remote interior angles, the sum of the two remote interior angles. So therefore, the measure of an exterior angle is greater than either one of the remote interior angles. So if you're comparing the three angles, angle 1 has to be the largest angle. And piggybacking off of that, we have this concept. This is the concept I really want to get to. If two sides of a triangle are not congruent, then the larger angle lies opposite the longer side. So if you look at the triangle, when you make the angle larger, the side opposite it has to get longer. You know, think about it. If I have two angles here, I'm going to kind of create them with this, and I have to make this angle larger, then what's going to happen at the ends is the side has to get larger. The smaller the angle, the shorter the opposite side. So in this case, the larger angle would represent the larger side opposite it. And in the same way, if two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. And so that's a pretty easy concept to understand as well. And then the third concept here, which I want to talk about, is simply saying that in a triangle, the sum of the lengths of any two sides of a triangle is always greater than the length of the third side. I mean, think about it. If two sides, if these were not greater, if xy and yz were not greater than xz, we couldn't make a triangle out of that. The two sides would fall, they wouldn't touch before they got to the actual segment. So we have to have this triangle inequality theorem. Two sides, the sum of two sides always has to be greater than that third side. So that's taking a look at the notes. Let's take a look at a couple of examples here. See how this works out. So the question is, if we look at this triangle, why is angle 2 larger than angle 3? You can't just say, it looks larger. You can't say that. We have to prove it. Well, if I look at this triangle right here, it's isosceles. So therefore, angle 1 and angle 2 have to be congruent. So angle 2 is congruent to angle 1 because it's basically the definition of an isosceles triangle. I'm not doing a proof here, but I'm just going to show you. So that's an isosceles triangle. Those are the base angles. They have to be congruent. All right, let's key in on angle 1, 3, and 4. Key in on this triangle, ABD. 3 and 4 are the remote interior angles of the triangle when the exterior angle is 1. So therefore, according to the theorem, we know that the measure of angle 1 has to be congruent to the measure of angle, I should put measure in front of this, angle 3 plus the measure of angle 4. All right, let's make this an equal sign instead of a congruent sign because I want to talk about the measure. So that's true because they're remote interior angle theorem. Okay, well remember, angle 2 is congruent to angle 1, so that must mean the measure of angle 2 is also equal to the measure of angle 3 plus the measure of angle 4. Right? And since that's the case, look here. Angle 2 has to be larger than the measure of angle 3 alone, because we have to add another angle to it to make it equal to the measure of angle 2. So that has to be true. All right, knowing that, let's take a look at this question. Which two streets form the corner with the largest angle? So I want to know where the largest angle is located. So instead of looking at the angles, look at the sides. This is 175, 120, 105. This is the longest side, so therefore opposite it right here would be the largest angle. So we're looking at MLK Boulevard and Valley Road. That is the largest angle of that triangle. Next question, put the sides in order from shortest to longest. Well, I probably need to find out what that measure is, since we could take 180 from these numbers. Let's do that here. 180 minus 58 minus 62 gives us 60 degrees. So there's a 60-degree angle there. Hope you couldn't see that, I don't suppose. There you go. So now that I see that, the shortest side would be opposite the shortest angle. That's the shortest angle, so TV would be the shortest side. The middle side then would be opposite the middle number, so UV would be next, and that's going to leave us opposite 62. TU would be the longest side. Simple as that. Can a triangle have these given lengths? Let's take a look. First thing I want to do is I want to take the two shortest sides and I want to add them together. Do they equal 8? No. Are they greater than 8? If they are greater than, then yes. You got a triangle because they are larger than that longest side. You only need to check the two shortest sides against the longest side. Over here, the two shortest sides are 5 and 10. And then we got 15 over here. Well, those are equal, so therefore, no, we can't make a triangle because those two sides would actually lay right down on top of the side 15. So you're not going to have a triangle there where you will on this one. And last but not least, we have two sides of a triangle are 8 feet and 5 feet and 8 feet. What's the range of the third side? So we have a triangle that we can move around here. So basically, the shortest side we could have would be taking the 8 minus the 5. So if you subtracted that, you'd get 3. So the shortest side that the triangle could have is 3. It actually can't equal 3, but it has to be slightly larger than 3. And the largest it could be is 8 plus 5, 13. Again, it can't equal 13. It's got to be slightly smaller than 13. So anywhere between 3 and 13, we would have a triangle here. So x would be between 3 and 13, not equal, so don't put a line under those. And that would be the range of the third side and if we wanted to have a triangle. You simply take the two opposite sides, subtract them, and then add them, which we did here and here, and then it's in between those two sides. And there's a look at our notes and our examples for section F5.